I'm here to talk to you about Amundsen. Let me tell you something first about the team that I'm working in. This photo was taken at one of the awesome Coolblue parties. They were really fun. I'm working in a data systems team that is still using a more centralized data warehouse, but we also connect with other people, a lot of business analysts that are really taking the decentralized approach to data and making the company data-driven. Something about myself, I actually started in IT in 1998, and I joined Coolblue as a data engineer in 2016. I'm also painting, so this is one of the paintings from a workshop I did in Florence, which is a lot of fun. Before I got involved with Amundsen, I actually made a project called Databook on GitHub. I didn't get any developers, but it was modeled after Data Portal from Airbnb, which I thought was a really cool way of starting to work with data and data discovery. So something about Amundsen, who was he? He was a Norwegian Arctic explorer. He was the first one to go to the South Pole, and he was the first one to traverse the Northwest Passage by sea. So that's a little bit about his background. He was really tough as nails, because he also got involved with fights with Arctic or polar bears and so on. So data discovery, it's important to give a little bit of context about why Amundsen came to be and what are the problems that we are trying to solve. And basically what it means is that when you get decentralization and democratization of data, you cannot really make it productive unless you use tools to also give people the information about the plethora of data that they are going to create. So for example, 20 years ago we had BI, and all the data warehouses, they were centralized with a centralized team, and the centralized team would know everything about the data, how it was produced, and people would go there with feature requests so that they get a little bit more data to make decisions on. Now, with data increasing significantly in big data, we're getting a lot more data from different sources and third parties, and it makes it a little bit difficult to really understand how the data is being processed, and also all of those data products are now becoming decentralized from a single team. So you get multiple teams doing things with data, and also connecting those data sources together, which makes it quite a bit of a challenge to understand what you're really working with, what is available throughout the organization, and how those data products are built. So those are the challenges. So one of them is, for example, if you think about a case where you want to analyze the price elasticity for MacBooks, then there's a couple of questions that you're going to have to answer when you're a business analyst, for example. So the first one is, do we have data for the sales, and do we have data for product prices? Do we have some market share data, perhaps, that we can see how the prices are against the market in order to start answering this question? The second question that you will get is the data current, up to date? Is it actively monitored? I've seen a couple of cases where the data itself is produced or was produced historically, but then never really updated, or the data isn't really monitored where it is produced, so that it might actually contain errors or bugs in the processing. The price column has some kind of specifics on how it is built. You need to have questions about if it includes or excludes VAT and other kinds of products that could be in there. If you look at a margin column, that has probably a lot of different components that can change over time. Because if a team that is building the margin starts to include additional costs or some other kind of profits that you didn't count on, that can have some severe consequences on the way how you regard those particular values in those columns. And the actual price that is listed, is it an actual sales price or is it the list price of the product? So when you look at the product information, it isn't necessarily the price for what it is advertised on the web shop. So those are a lot of those issues about the uncertainty with data. And then, of course, what I deal with a lot myself is that we are having some data products that we are building on some RDBMS or data warehouse data systems like SQL Server. And at some point in time, we notice that it doesn't really handle the processing or the load anymore. And then you need to relocate that to some other location, for example, in BigQuery. And that means that you're going to phase out a data product on SQL Server that people have built dashboards on. And then you want them to point to a BigQuery data source instead. How do you manage that process? You need to understand who is using your data, what they're using it for, and how they're building those dashboards. And they need to realize that something that you have built or is actually are producing is then going to change and has to be rewired to some other data system somewhere else. The other thing that you also see happening is that there's quite a lot of churn also in retail. Every 2 years there's a large bunch of colleagues that are leaving and new ones are joining, and they haven't really gone through the whole history of how the company was built. So when they get a question about the list price or the margin that they need to look at, then they start to ask questions like, well, where is that data? How are other people using it? How did this get built? What is somebody else doing? And between category teams, for example, you have one with televisions, another one with kitchen equipment. You can also have similar equipment or questions where the kitchen equipment people are using the data in a particular way to look at that data slightly differently to answer some different questions. You want those people to also be able to talk to one another and see how they're using the data in different ways, because it can also help your own category team. So what we have in essence is basically you have this branch of uncertainty about the existence of the data, how it is built, how it was, how it was before that, and what the source of the truth of that data is. So data lineage as well. A side effect of people not knowing is that they're going to run a lot of different select star queries just to find out what this data is about and make some guesses. And quite a huge part is Slack that we're also using, where you see people creating channels to talk about issues and ask questions exactly related to the knowledge that you need in order to start using the data. So that those people are just raising their hands like, is there anybody available who knows something about this kind of data, how it was built, and so on. So that's quite a lot of interruptions that you get throughout the day in order to deal with those, and you keep answering the same questions over and over because of the churn that you have with new employees joining and leaving. So what you could say is actually that in order to go to the next big data wave, metadata is quite a key factor in order to do it, and these are some of the reasons why that is the case. Like, we need to understand more about the trustworthiness of data, where it comes from, who is using it, and network with other people on what they are doing with the data analysis, how they are using it, keep that knowledge more widespread instead of making it tribal pockets in different locations. And you want to know also about the upstream producers of data and notify your downstream consumers, because if your data products are going to change, they need to know about it, otherwise it might break their data products and they might not even be notified of that, and maybe only discover a month afterwards, right? And also when Lyft is looking at this, because Amundsen is from Lyft, they noticed that they could actually acquire a 30% increase in productivity for the data scientists, because they didn't have to ask around and talk to other people to figure out what to do, but they could just use these kind of tools in order to figure out where to get the features from. So when you think about the whole problem area, there's a lot of things related to relationships. People are looking at dashboards, users are working together on different things related to the data. A dashboard is drawing the data from a table, one table is created from another table. And when you think about those relationships, they will eventually come back as a kind of graph that you can use in order to figure out all this metadata and these relationships, and to be able to ask it questions on what to do. So there's a Berkeley research group called Ground, and they have established a theory on metadata as well, which is called the ABC of metadata. And that is related to the application context. So where is the data located, and the semantics of the data, what they need to figure out in order to operate. There's the behavior about how people are using the data and who's creating it, and how that changes over time. That's where you see the time factor coming, that's pretty important. And the change in the data. The company, the organization is developing, evolving. You might have some agile development in place. You start out with a simple proof of concept, and then over time you build that into properly, a product that is properly productionized. So all of those things have some impact on the way of how data products are evolving and how the organization is using it in a decentralized way. So what Lyft did was, before they started on this project, was to look at the things that were available. There are obviously vendors that sell products, Alation and Colibra. There's a couple of existing open source projects, and also there's the academic initiatives that are available. And Google has also a data catalog available right now that is mostly focused on the Google BigQuery side of things. So now that we understand the problem a little bit, we can start to think about the needs that we have for the something that you want to build as an open source project. And so one of the things that was identified is that you need to have a tool that allows you to search for the data. So the first question becomes, how can we respond to user queries like where data is located, exactly what kind of data it contains and how that is built. And at Airbnb, for example, they all have it mixed with a tool that allows them to also record analysis that they have done on notebooks, for example. So when you go through the questions, you can also see some kind of the knowledge base, creating a knowledge base in order to get those articles out. The other thing that is related to this discovery is about figuring out who the owners are of particular tables or data products, and also to be able to notify people downstream. So there's a lineage question involved that will also have to be addressed somehow. And there's a network-based issue where you want to be able to group people together that are related or working on particular pieces of the data and that can benefit from one another. So then you can also, bookmark tables, get notified of things that are happening, and also see what other people are doing. So the other requirements that they had was that they wanted to leverage as much data automatically as possible. So they don't want to have a system where you have to manually create a lot of the data to re-specify some of the information that already exists as metadata in Hive or in BigQuery, for example. And they had a slight preference for open source as well. So these are some of the, they had a look at some of the projects that were available from that perspective, and they were mapping that out to the search-based, lineage-based, and network-based properties they have. And what you see clearly is that Data Portal is the only one that is network-based, and that is because that's basically what I would call the data book or the Facebook of data, is that it is not just about the data products that you have, but it is also about the users and how they're using the data. So that you get this huge network of data tables, dashboards, graphs, and so on, but also related to people that are actually using them or producing them. And that is a necessary factor in this question. And then there was a couple of support for particular tools that would be very helpful to have. So the actual requirements that they have was that they wanted to have the trust embodied in the solution itself, and that is based on the search queries that you would do. So when you do a search on particular data item, let's say passenger, you would actually get the search result sorted in order of relevance and popularity. Very low amount of manual curation, so try to automate the actual ingest of all the metadata through automated processes, instead of having manual processes where you have to do manual typing and so on, because that will easily run out of date, and before you know it, people are not using it anymore. I will go back to how you would actually do that on Amundsen. And a slight preference for open source. Data Portal isn't open source, unfortunately, so they didn't go with that, and they built Amundsen instead. So clearly what they looked at, because of the missing network element, the targeted user experience was not available in any of the other tools that they have looked at. So I'll show you a little bit about the user experience that you would get. So when you go to Amundsen, you have a landing page, and it's more or less like a Google search page, a simple search box at the top. And then the popular tables are already listed on the front page. Those are the most common tables that anybody working for that company would probably utilize. And typically you would find tables like margin, or depending on what kind of company you are, you would be looking at rides and passengers because you're working with Lyft, for example. So on the search page, when you type in some element, it is going for all of the data using an ElasticSearch backend. And there you would get then a couple of results related to that particular term. And it could be that it is a table itself, or it could be that there's a column in there. And so it's basically an Elasticsearch search that has different factors on the importance of that particular term. But you can also search for particular tags. For example, you can search only on columns. You can also search for tags that you add yourself to the table over time. And when you go into one of those tables, you can see that you then get all the columns out. You see the type of the column, and if there's a description that is also listed, those descriptions and the owners and some of these attributes of the table can be modified inside Amundsen. So you can actually complement the information over time, but it is not propagated back to the source system because of reasons with GitHub and the way how that code is stored, that you don't really know that up front. But you can extract it and then eventually put it back into the column descriptions if you want to do that. So here you can also see the owners on the right side. So over here somewhere. And here you see some other frequent users that you can actually get into and talk to them to see how they're using those tables so that you can learn from that. There's an Airflow icon that tells us how the table is populated, in which that happens, and the source code repository and a preview. So if you go into the column details for one particular column, then you can see also some metadata about a particular column. So over the whole column and all the rows, how many nulls are there, what is the column or the row count, the distinct elements, and so on. So you can get an idea about what is really contained in that column for that particular table. Then there's a particular link that you can use to figure out a preview of the data, so you can actually see what is in there. And next to that, there's also the people search. So if you know that somebody else is a colleague who is, doing very similar work that you are doing, you can see what kind of tables they're using, what kind of tables they own, and some other kind of things that they're bookmarking. So you get an idea about how they actually execute the work, and maybe look at this tables yourself and learn from that. And here's a more detailed overview from the bookmark tables and frequently used tables. And the way how you can also use that with bookmarking, that when email notifications get used, you can actually get notified by the platform if there are changes in the process or in those tables. So what I'm going to do now is talk a little bit about the design of Amundsen. It's a more technical part. This is the overall design, how things fit together. If you focus only on the front end, what you just saw, then the front end is the user web interface, but it also has the search service, which is basically used for the search function only. But there's also a metadata service, which is where it gets the actual metadata from. So there are two different services that it talks to in order to render the pages. So these two services, the metadata service is a Neo4j graph database. I'll get into a little bit of detail why that database is chosen. And ElasticSearch is used just to populate whatever is in Neo4j inside ElasticSearch as well for the search purposes. And what we have below that, because I said they want to do automated creation as much as possible, then in order to support that, you need to have quite a lot of crawlers. You need to have data builders, so extractors for different databases. So there's an extractor for a Postgres database, something for Hive, for Redshift. I contributed one for BigQuery. And then as soon as you extract the metadata from all those databases and you put them into Neo4j, then over time you have a complete metadata set that you can use to see how that data is being used. And there's also some other links that are still being developed for exporting the lineage information and metadata from Airflow into Neo4j as well, so that you can see how a DAG is being utilized to read from a particular table or database and put that into another one. And the metadata service itself is not only available for the front end, it is actually an API. And that service, it can also be used in the future. Some things are already being developed for extracting machine learning features, for example. Because as soon as you have this metadata available for querying through the front end, why not just use it for other automated processes? Think also about PI data and tracking how your PI information is being propagated through the system, and where some of those users might actually violate that, right? So when you add more to this whole metadata database, you can start asking completely different questions from different systems that you can actually use and integrate together. That can be very useful. So as I was saying, a lot of the things are about the relations, and these relations, it's more about the relation itself and over the entities that you're using. In a traditional RDBMS, you'd be thinking about tables, and then it's about those entities, the order line or the order. But in a graph database, the focus is on the relations that they have with one another. So you would have some labels, or you have some little information contained in some of those entities or the nodes. But then mostly it's about how those nodes are being used and what kind of relationship they have between one another. And here you see an example of a database that you can declare as a node, which has schemas, and the schemas have tables, and the tables are being produced by some person. And there's an Airflow DAG that actually uses that. And there are columns inside those tables, and those columns have some other properties. So all of them become like a very complicated, well, quite a large graph actually, that is then utilized to query, right? And then from those queries you can extract all the metadata and see how those things are being utilized. So getting into a little bit of code here on how that would work. On the left you see the SQL part of getting a first name from person in an RDBMS using SQL. And on the right you see a Cipher query for the graph database where the language looks a little bit different, but these are equivalent queries. On the next level, you see that we have a join, and then on the RDBMS, on SQL, you have to actually make a decision on the structure of the table. So the structure of the table is being modified to support a particular use case where there is a relationship between a person and a team. On the graph database, you don't need to do that because you can just create relationships on the fly. You don't have a formal formulated, how do you say that, a formal structure in order to insert the data. So you can actually just insert all kinds of relationships, but of course you need to have the knowledge that they exist in order to actually use them properly. So here you see that the join that we have over here is modified to become this kind of query, where you specify the type of relationship that you want to look for in this case, and then the outcome is here also equivalent. And on the next level, you see how the graph database is starting to change. To be able to answer this all kinds of different questions in SQL, you need to have this structure in place. It needs to have that table schema. But on the graph database, we can actually look for all kinds of different, relationships. And here it basically specifies any relationship between these two people, right? And that means that you don't really care about the type of relationship, but just some kind of link between them when you want to get the output. And that's how these graph databases can be very useful. So on Elasticsearch, we have the search and relevance queries as well. So as we said on the search page, we want to do the normal search, matching the records based on relevancy. But there's also the category searches. So one of them could be like you want to look for something specifically on the column name, warehouse cost, and also wildcard searches that would complete. So that's basically the full grammar that you would get available for the Elasticsearch queries that you can execute. The metadata extractors, they follow a pattern from Apache Goblin. That's a kind of architecture where you do the extraction in stages. First you get the data out, and then you have another process that would be able to transform the data into something else. And then all of the extractors and what we call the data builders, they are creating these hierarchies of these different structures and classes and put them together in order to create the input data that we need for the graph database. So this deals us to be able to talk to different systems like Postgres or BigQuery or any kind of other system without having to make it too messy, right? Because you can just substitute classes and put them into a pipeline together. And this is what it looks like when you put this on Airflow. So, the Airflow DAG would just look at a particular system and extract all the metadata from that particular database. So, for example, here you have a Postgres database, could also be a Hive or some other BigQuery project, for example, and then it would insert all of that and publish that to Neo4j graph database. So when you start your journey, there's a couple of things that you have to look into, because when I started with Amundsen, there were a couple of things that I found a little bit difficult in the beginning. So when you look into this, you need to allocate some time for that, right? So some of the things I looked into was customizing the user interface. And the user interface has a couple of, you need to actually modify some things that is not very easy to do in the beginning. It's not like simply uploading a picture, for example. You have to actually dig into the source code and figure out how that's done. There's a security and OpenID Connect for authentication, But on Amundsen, you don't have what we call authorization or access control lists. So whatever function is available for you to write or edit data, anybody can do that. And you don't necessarily need to log in, but it is useful to log in because you want to know your own authenticate for the purposes of figuring out which people are related to you and what kind of tables you use. And at ING, for example, they have an OpenID Connect system, and they are using Envoy with Lyft in order to create the same authentication tokens and propagate them to the end services as well, so that the whole setup is secure. But you could put, for example, a proxy in front of the user tool, your user UI tool or a web server, and then use that to just authenticate and then have the metadata services located only accessible from the web server. There's a couple of extractors that you need to identify. So I was already seeing that the BigQuery wasn't there. I made a pull request for that and I contributed that one. But there's also other things like SQL Server isn't there, and it might be necessary that you write some of your own extractors. Specifically GitHub and Active Directory, for example, they would be very useful, but they are very difficult to generalize because the way how we deal with GitHub repositories and deploy the source code is very different from other companies. So you can't really create a general extractor for that purpose. You would have to do a lot of coding. So those are some of the things to look into, what extractors are available and what kind of data you can actually get started with. And then, of course, building the DAGs in order to put all of that together. There's a sample available that will allow you to run this on the command line, but it's not yet on Airflow. But then when you want to run this on Airflow, you need to build the DAGs and put all the metadata or the information and make that available so that you can actually build the Goblin-type pipelines and run them from within Airflow. So the roadmap, that's also quite interesting for Amundsen, what they have identified. They are going to redesign the user interface over time, so that's quite interesting. There will be more focus on email notification system. So right now email notifications aren't really in place, but it was identified that can be a really good extra feature to be able to know more about the changes that are occurring on the metadata side, on the schemas. And dashboards for Tableau, Data Portal has it already, and with those indexing abilities, you can then see which users are accessing which dashboards, so that you can start asking questions, who is looking at which data or producing it, or who has created that particular dashboard. Lineage integration, as I said, with Airflow, that's more or less like a plugin into Airflow that would transfer the way how the data is utilized inside the DAGs, and more access level control. For example, restricting who can edit the metadata and who can only read it. And at the moment, there is no access level in place at all at the moment. And of course, more metadata sources, like additional database types and database systems. And there's going to be a little bit of focus on the services and teams and streams as well, I think, in the future. So that's quite interesting. Challenging roadmap. And as I was saying also about the metadata, when you think about the data discovery, what we have done now, it's basically putting all of that metadata together so that people can see it. But it is from there a smaller step towards data governance, because you can, from the metadata graph database that you have in place, query it and then figure out what you need to do for having compliance with GDPR, for example. Have a look at data quality, maybe use a preview, and all of those different API functions. And the downstream impact analysis as well could be created as a tool, so that you just have to select the table that you want to modify and see what other downstream products would be affected by that. So you can do an impact assessment. When I am working at Coolblue, you can easily see that. There's often a question about who's using this table. And people need to put their hands up and say something. If they are not in the office or they don't see the message, then the table gets modified and some data products break. So to be able to do that autonomously without other people involvement is a great thing to get, right? So we also look at some other users. We've started to look at Amundsen already. We're not actually using that in production at the moment, but the Slack channel has a couple of different users. There's quite a large number of companies already involved. And I think that's quite interesting, very exciting. And this is where you can find out more about Amundsen and over the Slack. So there's a Slack channel basically where people communicate. There's not a mailing list at the moment. It's also not on Apache yet. It has been recently open sourced only in October. And the repository that you see on GitHub is basically where you can get more information and try it out. There's a relatively easy setup. When you want to do the quick start, it's only 10 lines in the command console in order to get a couple of Docker containers downloaded and start working with that. That's my talk. If there are any questions.